Okay, graph symmetry. This is going to be a fairly simple video because we're going to use the graph that is displayed on our graphing device to determine symmetry. Our objective, use the graph to determine if an equation has symmetry with respect to the y-axis, with respect to the origin, or neither. Okay, well, first off, what is symmetry? Symmetry is when two or more parts are identical after a flip, a slide, or a turn. All right, after you flip, slide, or turn. Specifically, y-axis symmetry is reflection symmetry, or symmetry about a line. The graph has y-axis symmetry if one side of the y-axis is the reflection of the other side of the y-axis. We'll be focusing, that's one of our two things we're going to focus on. Origin symmetry is rotational symmetry, or symmetry about a point. Okay, our graph will have origin symmetry if it looks the same, in other words, if it lands on itself after less than one full or 360-degree rotation about the origin. So we're going to stick a tack in the origin, and we're going to spin it right around the origin. We're not going to concern ourselves with the algebra, how to do this algebraically. We're just going to use the graph to do this. Just see it on our graph. Keep it very simple because we have graphing devices, and that'll do it for us. So let's take a look at a few examples here. And this will be pretty cut and dry. I think you'll think, oh, this isn't that big a deal. Example 1, determine if the graph of y equals x squared minus 1 is symmetric with respect to the y-axis, the origin, or neither. Well, let's simply graph it. Y equals x squared minus 1. I'll take out my graphing device. I'll go turn it on. How about I turn it on first? I'll go into y equals, and I'll put in y equals x squared minus 1. I think I'm in the standard. I'm going to zoom to standard to make sure I may not be in the standard window. And here's my graph. And with y-axis symmetry, is the y-axis a line, symmetry is the line of reflection. Does the right side flip over the y-axis and land on the left side? And vice versa, is a reflection? And you can see clearly that yes. This side of the y-axis is reflected on this side of the y-axis, therefore it has y-axis symmetry. So this one has y-axis symmetry. I can just put right y-axis. Now notice, if I go back to here, if I put a tack at the origin, so I put a tack right there, I got to spin it all the way around 360 degrees to get back on itself to get the same picture. So it does not have origin symmetry. Okay, does not have origin symmetry. Okay, how about number 2? How about the graph of y equals x cubed? Is it symmetric with respect to the y-axis, the origin, or neither? Let's go into here. We'll go back to our y equals, and we'll change this one to be x cubed. So I'll put in x cubed, and I'll press graph. And here you have it. Does it have y-axis symmetry? Okay, is one side of the y-axis the reflection of the other side? And you can clearly see no. This part above the x-axis does not reflect over here. And this part below the x-axis does not reflect over here. So there is no y-axis symmetry. Does it have origin symmetry? Let's put a tack right here at the origin. I'll tack myself right there. Can I spin it and have it land on itself after less than one rotation? And the answer is yes. I just got to spin it halfway around, and I'll land right back on. The graph will land right back on itself. So this one has origin symmetry. So this graph is symmetric with respect to the origin. Okay, last one. This graph is symmetric. How about this graph, which is 2x cubed minus 3x squared minus 11x plus 6. This is a third degree polynomial. We'll learn about that coming up. Let's see if it's symmetric or not. So we'll go into here. I'll go back to y equals and clear out. Now I need to put in 2x cubed minus 3x squared minus 11x plus 6, and I'll press graph. And there you have it. And it looks like my graph is actually above and below. I need more y. I'm going to go to Window and give myself a little bit more y. I'll go y minimum to negative 15 and y maximum to 15 because I want to see the entire graph. I think this will do it. That's better. Okay, well, do I have y-axis symmetry? Here's my y-axis. Does the right side reflect to the left side? And you can clearly see the answer to that is no. I'm not reflecting on either side and getting the same thing. Do I have origin symmetry? Well, if I put a tack right there at the origin and I spin it, I'll notice that I'm not going to get the same graph until I go a full 360 degrees. In fact, it's crossing up here. It's crossing up here. So it's not going to happen. It's not going to rotate around the origin here. So it does not have origin symmetry either. So this graph has neither y-axis symmetry nor origin symmetry. So we'll say neither. Again, you can determine symmetry algebraically. We are simply going to determine symmetry using the graph of the function or the graph of the equation.